Morning everyone. It's about the minimization of DFA. So, my name is Tejasv Goyal.
My name is AARYA.
First of all, the question arises, what is DFA? So, the DFA refers to deterministic finite automata. Deterministic refers to the uniqueness of the computation, and the finite automata are called deterministic finite automata if and only if the machine is read an input string one symbol at a time. In DFA, there is only one path for specific input from the current state to the next state. DFA does not accept the null move, that is, the DFA cannot change state without any input character. That specifically means that DFA cannot change the state if the input is not given. DFA can contain multiple finite states. It is used in lexical analysis in computer.
Formal definition of DFA. DFA is mainly represented using 5 tuples. Q, which is used to represent the final state. Sigma, which represents the finite state and of the input symbols. Q naught, the initial state. F, the final state, and delta, the transition state. Delta in finite automata is defined as Q cross sigma till Q.
The minimization of DFA, which is our the main topic. The process of reducing a given DFA to its minimal form is called minimization of DFA. In minimization of DFA, we contains the minimum number of states that the DFA can, we can say like it can express into. It has been written also like it contains the minimum number of states. The DFA in its minimum form is called minimal DFA. This question can be asked in your like MCQ type question.
Minimization of DFA is mainly performed using the following steps. Suppose we have a DFA represented by Q, sigma, Q naught, delta, and F, which recognizes a language, say L. Then the minimized DFA D, Q dash, sigma, Q naught, delta dash, F dash can be constructed for the language L such as.
So now, where the step one is, we will divide Q, that is a set of states, into two sets. One set will contain all final states and other set will contain non-final state. This is the partition called P0. Basically what we do, like we contain two sets in which one the final states is there and one non-final states is there. In non-final states, we also consider the initial state, which is being represented by this symbol, and final state has been represented by this. Okay, so the step 2 is initialize k is equals to 1. Now step 3 is find pk by partitioning the different sets of pk minus 1. In each set of pk minus 1, we will take all possible pair of states. If two states of set are distinguishable, we will split the sets into two different sets in pk. Now let's go to the step 4. Stop when pk is equals to pk minus 1, means there is no change in the partition. Now the last step to get the minimization of DFA is all states of one set are merged into one, and the number of states in minimized DFA will be equal to the number of sets in pk. So now we discuss questions. Like theory part is now over, and now we discuss the time to problem solving. Thank you.
Now here we have been given a DFA with 5 states to minimize. Let us first construct the truth table for this given DFA. Where A is the initial state and D is the final state. Let us see where A goes when input is 0, when input is 1. Similarly, we can fill up the rest of the table. Now let us first perform 0 equivalence on the given DFA. In 0 equivalence, we first divide the given states into non-final states and final states. Here E was the only final state, so only it is kept separately. Now let us check one equivalence. Now we see where A and B are going for the input 0 and 1. We can see that A goes to B and for input 0, and B also goes to B for input 0, while A goes to input, while A with input 1 goes to C and B with input 1 goes to D. Though C and D are in the same group which they were in the initial set, so we can keep them together. Now let us check if C can also be added in the same group. C also goes to B and C, which were in the same group as before, so we can leave this in the same group. But D for input 1 goes to E, so E is not in the initial group, so we have to keep it separately. Now E is the only one left, so E is anyways by itself. Now let us check two equivalents for the same. A and B both goes to A, but like now in A and B we can see that B goes to D, so B cannot be kept in the same group as A, so A and B are kept separately. Now both A and C go to the same states for the same input, so A and C can be grouped together. D was anyways by itself and E was by itself. Now let us check third equivalence. As we can see, there appear to be no new groups that can be formed, so we can stop this process of creating new equivalences and go on to creating the new truth table with these new equivalent states that we have achieved. A and C both go to the same inputs, same positions for same inputs, so we can write them as they were in the initial table. B also have the same. E goes to B and C. Now let us draw the new DFA that we have achieved using this equivalence. AC is created a new state, which is the initial state also, because A was the initial state and E is still the final state. B, D, E. AC goes to B with input 0 and AC goes to C with input 1. B goes to B with input 0 and goes to D with input 1. D goes to B with input 0 and goes to E with input 1. E goes to B with input 1 and goes to C. Sorry, E goes to B with input 0 and AC with input 1. Here we cannot write C as C has been made into a new group, so we should write AC over here. In the second question, we have already been given the truth table for the DFA, so let us divide them into equivalences first. 0 equivalence. As we know, in 0 equivalence we divide them into two sets based on non-final states and final states. So Q1, Q0, Q1, Q3, Q4, Q5, Q6, Q7 are all non-final states and only Q2 is a final state. One equivalence. Q0 goes to sets Q1 and Q5. Q1 goes to states Q2, Q6 and Q2, but Q2 is a separate set, so we have to begin a new set called Q1. Now let's check again Q0 and Q3. Q3 goes to Q2 for input 0, so it has to also be a new set. Next, Q0 and Q4. Q0 and Q4 both have elements in same sets, so we can group them. Q0 and Q5 have Q2 different, so we cannot group them together. Let us try with Q1 and Q5. Q1 and Q5 have difference of elements, so we cannot group them together. Now let us try Q3 and Q5. Q3 and Q5 go to the same states, so we can group them together. Now Q6 can be grouped with Q0, and similarly Q7 can be grouped with Q1, and Q2 is left as it was before. Now two equivalents. So in the first group, Q0 and Q4 have all elements in the same state, so they can be left together. And Q6 has elements in different states, so that will form a new group. The remaining elements remain as they are. And Q5. Now let us check for third equivalence. All states appear to be in the same state, so I think we can stop checking for equivalence after this step. Q3 and Q5. Yeah, all are in the same state, so we can stop checking for new equivalences. Let us now create the new truth table after these new values have been achieved. Q3, Q5, and last Q2. Q1, Q0 was the initial state, and Q3 was the final state. Q2 was the final state, sorry. Now Q0, Q4 goes to Q1, Q7 in the input 0, and Q3, Q5 for input 1. Q6 remains in Q6 for input 0 and goes to Q0, Q4 for input 1. Q1, Q7 goes to Q6 for input 0 and goes to Q2 for input 1. Q3, Q5 go to Q2 for input 0 and go to Q6 for input 1. Q2 star, which is the final state, goes to Q0, Q4 for input 0 and Q2 for the input, and remains in Q2 for the input 1. Now let us design the new DFA that has been achieved after equivalence. Q0, Q4 is the initial state. Q0, Q4 goes to Q1, Q7 for input 0 and goes to Q3, Q5 for input 1. Now Q1, Q7 goes to Q6 for input 0 and Q6 can remain in 0. Let's see, Q1, Q6 goes to a new state Q2, which is also our final state for input 1. Now Q2 remains in itself for input 1. Q3, Q5 goes to 0. Q2 goes to Q1, Q4 for input 0. Then Q6 comes back to Q0, Q4 for input 1. And Q3, Q5 goes to input 6 for input 1. And I think that is the new DFA that we have achieved.
So now it's the time for the third question. In this particular question, there are 6 states are given. So as we have seen in the previous questions, we just make the transition table.
these are the respective inputs, and from going to A, B, C, D, E and F, these are the inputs. And like similarly we can say B. First of all, I'll make the table. Now, after getting the table, the first thing you have to do is making the 0 equivalence, 1 equivalence, 2 equivalence and so on. So first of all, I'll just do for the 0 equivalence. So what you have to do, actually correct what you are saying is C, D, E, these are your final states, and A, B and F, these are the initial states. Not initial we can say, but non-final states we can say. Okay, after this, the first equivalence we have to take. What we are doing here is the same what we have done in the previous questions. So on getting input 0 and 1, A is going to B and C, but B and C is going to different sets. So A is there, and after that B, A will checking the equivalence for AB. AB, like on getting input 0, they are going into A and B, which is in the same set, and on getting input 1, which is going into C and D, which also are in the same set. So you go A and B. So now A and B are the equivalents. Now it's time for check for A and F. We can check for A and F or B and F. Both were equal because like A and B is the equivalence. So A and F, for getting input 0, A and F both are going in. One A is going in B and F is going on E, and E is in different set and B is in different set. So F is in different set, and so C, D, E and C, D, E are in the same set. Like these are the final states, so we say these are in the same set. So time for second equivalence. Now for second equivalence we'll check like AB. Now AB on getting input 0, it's going on A and B, which is in the same set. So AB is the equivalence, as C and D are in the same set, and so same is this. As now you can clearly visible like first is equals to second equivalence. So now we have to stop the process and proceed to the we have to proceed for the main, like we have to make the another transition table, in which here we are only having the 3 states A, B, F and C, D, E. Only these 3 transition states we are having. So what we take is 0, 1, A, B, F, C, D, E. C, D, E are the final states, and A, B is the transition first state. So on getting input 0, A, B is going to be AB, which is in the same set. So we write AB. On input getting 1, which is going to C and D, and C and D are here is the set is state is C, D or E. Similarly we can do for F. For F it is going on F on getting input 0, input getting 1, it is going on F. So now C, D, E is going on C, D, E, and on input getting 1 going on F. Okay, now what we have to do is we have to make the transition diagram, state diagram, we can say transition state diagram. So for that, AB is the one state, F is our another state, and CD is our final state. So F is going on F on 0, 1. CDE is going on CD on 0. CD is going on F on 1, input 1. AB is going on CD on input 1 and its self loop on 0. So now it is your required answer. One thing I am like, yeah, it is incorrect here. This is F only. Actually, I had taken this F as solving, but here I had written incorrect. So now this is your required answer. This is a transition diagram. Thank you. Now this is the question for your homework. You can practice this question and the answer will be attached in the description box. So this is submitted to. Thank you.